All right, hello everyone, welcome back. This is the last questions requested by one of my students, Sydney. All right, so hopefully she'll be able to look through. All right, now for this question 6 here, it was extracted from the Passer paper 2019, November 2019, paper 33. Right, let's go through this. The complex number with the modulus 1 and argument pi over 3 is denoted by W. So therefore, we need to express this complex number in its rectangular form. All right, now how does that look like in this case? It will be quite straightforward for the first one. All the complex number can be written using this format here, which is its magnitude and then plus its argument. If you wish to represent it in terms of Euler format, it will be I theta, where the theta is the argument for this complex number. Right. Now the argument has been given as pi over 3 here. So all we need to do is just substitute this. We know that its magnitude also has been given as 1. Now therefore, this can be written as pi over 3 here, multiplied by 1 of course. Okay. And then how do we convert this Euler form back to its rectangular form? We can make use of the conversion, whereby all Euler complex form can be converted using its trigonometry format. We can write this in terms of its trigonometry form in this way. So there's cos pi over 3 plus I sine pi over 3 here. And then all you need to do is just key in into your calculator and then get the respective numerical value for this. This is typically a half. You press your calculator, and then this one is 3 over 2. And then there you have it. We managed to express this complex number W in its rectangular form, where all the x and y are real and exact in this case. Right, so I hope that is clear for number 1. Next, we're going to move on to number 2 shortly. Right, now we're going to proceed on to question 2. We're going to sketch the complex number u, which is given by 1 plus 2i here. And then we also given that the complex number v is such that the magnitude of v is twice the magnitude of u. And then the argument of v is argument of u plus pi over 3. So first of all, let's try to look at second section. Sketch an Argand diagram to show the points representing u and v. All right. Now, first of all, representing this using Argand diagram is quite direct in this case. All right, so all we need to do is just draw out the real component here, real axis, and then we have the imaginary axis. Okay, and then for this complex number u, it is 1 unit by 1 unit to the right, and then move 2 units up. So we have 1 and 2 here, and then there you have it. We have that complex number. Usually I would prefer to represent it using arrow. It looks very similar like a vector diagram, and then you just label that as u. If you like, you can label this as 1 comma 2 here, just to signify the position where this complex number is located on the Argand diagram. That is 1 and 2 here. And then its argument for this complex number u is given here, theta. And then this argument of u is now I have already labeled that as theta. If you wish to find out its angle or the argument for this complex number, you can actually take the trigonometry ratio or tangent. It's basically tangent inverse of 2. Now, if I were to use my calculator, right, that would roughly give me around 65 or 67 degree. So roughly, I would know that it will look something like this. All right. And then next, I have successfully sketched my complex number u. Now I'm going to proceed on to sketch my complex number v there. Now I know that v has a magnitude of twice the magnitude of u. So if this is the magnitude of u here, then therefore, okay, now if you are not sure what is the magnitude for u, you can always work it out. Okay, magnitude for u in this case will be, now that is quite easy, 1 square plus 2 square here, and then that will give me square root of 5. Therefore, the magnitude of v will be twice of cert 5, right? It will be longer a bit, right? And then where is this complex number v located then? Now it is located at an angle and an argument of the theta plus pi over 3, which is 60 degree. So all you need to do, just extend this another 60 degree. I would say roughly will be somewhere here then. This would give me the pi over 3. And then this is where my complex number v is located, right? Now you don't really need to represent the point there. Do we really need to represent the point? Okay, maybe we need to find out its points. You can see that we do know the points for u. We might want to find out the points for v then. Okay, we know that it has a magnitude of 2 sub 5 here, and then the angle will be somewhere here, another 60 degree from theta itself. Okay, and then thereafter we can figure out its point here, which is x and y. Okay, now that's how it would actually look like at this point. If you really wish to find out its position for, or the coordinates x and y for that complex number v, surely we can work that out, right? Now, based on this, we can write down the x, right? If you really want to find out the x coordinate here, x coordinate is basically, by using geometry, we know that the length of this complex number is 2 sub 5. Therefore, the x will be, I would say that it would be 2 sub 5. You can take the um, you can sort of take the sine or cosine in this case. I would say that that is, let's call this alpha then. All right, now that will give me cos alpha. But anyway, if you notice that this complex number fall in the second quadrant, so it should be a negative. There should be a negative in front here. Right? So I hope that is clear. And then how do I find alpha then? Now we know that theta is given by this, and then therefore alpha is just pi subtract off with theta, subtract off with the pi over 3 here, or mainly is pi minus theta plus pi over 3. Okay, now if you were to simplify this, right, it's basically just um, 2 pi over 3 minus theta. 2 pi over 3 minus theta. But anyway, you don't really need to do anything at this point. All you need to do is just substitute this. And then we know that the cosine of this must be equal to a negative. Therefore, at this point, right, we can write down this as negative 2 sub 5 cosine theta plus pi over 3. Okay, now you must be wondering, why is it not the same as pi minus theta plus pi over 3 there? This value is exactly the same. If you were to write down cos, all right, now the reasoning is here. We know that cos pi minus theta plus pi of this is actually equal to negative cos theta plus pi over 3. Right, now that's how it would actually look like. right? So here I'm just since I already have my negative, so I don't really need to write down cos pi minus here. I can straight away write this one down here. And then all you have to do right now is just to figure out what is the angle for this theta, and then add them up. You will be able to find the x coordinate here. All right. So here I just leave it up to this point. Now, anyway, for this question, I don't think they actually ask you for the exact point that you need to evaluate, since the marks is only 2 here. They just wanted to know roughly where the points are located on the Argand diagram. But here I give you extra informations on how to locate the point if you are interested to find out. All right. So that's it. Let me erase this off. We don't need this anymore. Okay. Now next, to locate or to find out the y coordinates for this complex number v, we use the same principle here. We can say that y is 2 sub phi, which is its magnitude sine alpha. Right. Now we know that sine alpha is exactly the same as sine theta plus pi over 3 because it falls in the second quadrant. Now, therefore, the y coordinate for this complex number can be written as this: sine theta plus pi over 3 here. All right, and then there you have it. Right, those x and y coordinates for the complex number v there. Right, so I hope that is useful to you. We're going to move on to the third one shortly. All right, now let's take a look at the last one. Explain why v can be expressed as 2uv here, and then hence find the v, giving your answer in the form of a plus iv, where a and b are real and exact. Right. Now I leave this diagram here just as a reference with respect to complex number u and v here. Okay. Now, first of all, these are all the information that has been given to us. I'd like to recap again. The complex number v is basically represented by the magnitude of v multiplied by its argument if you leave it in term of Euler form. So therefore, it will be I would say its argument in this diagram here, the argument for the v is given by theta plus pi over 3 here. You can see that from the diagram. That is the argument for the complex number v, which is given by this. All right, so I hope that is clear. And then from here, we can apply a bit of the um, index rule, index rule, and then with the help of this information, we can uh, extend that further to this. And then by applying the index rule, we can rewrite this as such. All right, now there you have it. This is how the complex number v look like in Euler form. Okay, and then we can rearrange this. Okay, so we can rearrange this as this. Okay, now there you have it. Now, just as a bit of reminder, from question 1, we have worked out the complex number w. The original form for complex number w in Euler form is given as 1 because it has a unit 1, modulus 1 or magnitude 1 here, exponential I pi over 3. That was given in the first section. And then if you compare that with this look exactly like the complex number w. Okay, and then next, as a reminder, the complex number u is written as the magnitude or the modulus of u, exponential I, the argument for u. Now, argument for u, I have labeled that as theta here. And then if you compare this with this, that represent exactly the complex number u. Therefore, Therefore, in this case, we can rewrite this as 2 will still remain as 2. This section here will become the complex number u, and then these sections will become the complex number w there. Now, that's how we prove that the complex number v can be written as 2uw. So I hope that is clear. And then lastly, it says that hence we need to find the complex number v in its rectangular form. Right, now I'm going to erase off this section here. Let's try to finalize the complex number v, which is not really any problem here. Okay, now v is equal to 2uw. All we need to do is just substitute whatever we have with regards to complex number u and w. Now we know u is this, and then w. Okay, w we have worked it out previously in the rectangular form. So just to recap, in its rectangular form, it is written as I sub 3 over 2. And therefore, we can substitute this over here. And then, of course, with the advanced calculator that you guys are having, you could have just type it in, and then it would give you the final form in its rectangular form, right? But if you don't have calculator like me, then you have to do a bit of manual calculations. Now, like this, for me, I would prefer to simplify the 2 with a half here, and then that will give me a much more easier expansion. I would say that is 1 minus, I'll straight away combine the real parts together. I will get 2 sub 3 here. And then after that, I will have sub 3, 2 plus sub 3, I. And then there you have it. That is the complex number v in its rectangular form. So I hope that is clear. I hope Sydney is clear on how to actually prove this part here. All right. So next, I'm going to after this, I'm going to make a corrections to one of my working on the previous video. It was suggested by one of my students after they checked through. There's an error in the solution, so I'm going to just make a bit of that correction and then try to include the rest of the working for your reference. Right? Okay. We're going to proceed on shortly. Right, welcome back. Now, this question was verified by one of my students, and then based on these students here, there is an error in my working. So here, I'll take this opportunity to make a corrections to these questions 10. I will include the descriptions for this past year paper. You can check out the description under the description section, of course. Right now, I think my main mistake is I forgot to put a square in my calculation. So that is mainly my error here. So I like to recap this again, how to solve A through two methods. Right now, methods number one, we are going to let W be the general form of rectangular complex number W, rectangular form, A plus IB here. Okay, where the A and B are all real numbers. Okay, that is our requirement. So from here, all we need to do is just substitute that using substitutions method. Now, the only thing I forgot to do is to square it, which is vital here. So this students is very sharp. Thank you very much for your verifications. All right. Okay. Now here we need to square this, of course. Okay. I'm going to square that, and then I'm going to combine the real parts together after I square it. And then I'm going to repeat the same procedure for my right hand side complex number. I'm going to expand that. All right, now you will see that the real parts has been cancelled out. Okay, only left with imaginary form. And then on my left hand side, I'm going to group the like terms, those imaginary parts together, and then the real parts together. And then I got myself 2ab plus a square minus b square I. All right, now through comparison, comparing the real parts with the real parts on the right hand side, and then comparing the imaginary parts, I will be able to form a simultaneous equation. So the first simultaneous equation that I'm having is there is no real parts on the right hand side. Now that's what I have. Of course, I can further simplify that, become 0. Okay, and then that is sort of my first equation. And then my second one will be a square minus b square must be equal to negative 8 then. All right. Now at this point of time, you must be asking yourself like a, b equals 0. Should a be equal to 0 or should b be equal to 0? Now let's try out that. If, right, if a is equal to 0, if a is equal to 0, right? Now, therefore, b, based on equation number 2, you have negative b squared equal to negative 8. Therefore, b is equal to square root of 8, which is 2 third 2 here. And then based on this requirement, the b is real number. All right, now that satisfies our requirement. We can take that. Let's try to check that. What if b is equal to 0? If b is equal to 0, then therefore a squared will be equal to negative 8. Then therefore a will be 2 third 2 I then. But based on our requirement that we have set, the a and b must be real numbers. Because of that, we can't actually take this second condition here. Now, I hope that is clear at this point. And then the other possibility is could both the AB be equal to 0 or not? Of course, you can check that very directly. AB cannot be 0 at the same time, or else the second equations cannot be satisfied at all. All right. Now, because of that, therefore we conclude that the W must be equal to, now because the A has to be 0, therefore there is no A anymore. Then B will have to be 2 third 2 I then. All right. Now that is the solutions to that complex equation. If you wish to check whether this is true or not, you can always expand, like apply a square to this, right? You'll find that it's exactly the same as that, right? So I hope that is clear at this point. All right. Now this is first method. Next, I'm going to clear this. I'm going to show you the second method to obtain the same solution, W equal to, I'm going to write this one down at the side here. We're going to compare whether using the second method would yield the same result. Okay. Now I'm going to clean this up here. We don't need this anymore, but I'm going to retain the definitions for the complex number that we are using. Okay. Now the second method, I'm going to use iw square is equal to 2 minus 2i square here. Now the same procedure apply here. We're going to expand this, which will give us like 4 minus 8i and then minus 4. That will give us a negative 8i. And then from here, I'm going to clean it up a bit. It's basically something like this. Therefore, w square, we can divide both sides by I. Then that will give us the I. That is negative 8. Okay. And then from here, we're going to square root this. If you were to square root this, we will get 8 square root negative 1. All right, now that is the same as square root of 8, square root of negative 1 here, and then that will give us a 2 third 2 I, where the I is, or I square is equal to negative 1. And then that matches our solutions that we have obtained previously from the first methods there. right? So I hope that would give you an idea how to solve A. This is partly my mistake, so I try to make a corrections for your checking. And then for B, I will also extract the solutions that I have produced in my previous video, so that anyone else that is reading this or viewing this video would be able to have complete solutions to section B also, right? So hopefully that will be useful. And then we are going to proceed on to B, right, with the extract from my previous video. All right, for second part, we need to sketch an Argand diagram showing the region R consisting of points representing the complex number Z as follow here. Now, we need to recognize this complex inequality, right, as a locus or a region of points that is found inside a circle that is centered at 4 comma 4 and then radius 2. Right now, in order to do this accurately and then safely in the exam, I would advise you to rewrite this form in this way. So we're going to factorize this. So there it looks something like this. The main reason why I want you to factorize this as a reminder that this is actually a circle. For this section, it represents a circle center, I would say centered at 4, 4. You can see that once you factorize that, you will write that as center as 4, 4 instead of writing negative 4, negative 4. Center at 4, 4 with radius of 2 unit. Yeah. But because this is an inequality, so there must be a region that is actually found inside that circle there. Right. Now I'm going to show you very briefly. This is a very simple task here. We have all we need to do is just draw the axis, imaginary, real. Right. This is the origin. Now there's around 4, 4 there, so roughly 1, 2, 3, 4 here. 1, 2, 3, 4. All right. Okay, from here we're going to mark down the coordinates. It should be around here, for instance. And then it has, oops, just let me correct my axis a little bit. I think I changed the scale a bit so that it's easier for me to relate to this. So let's start from 2, 4, 6, 8 here. 2, 4, 6, 8. Therefore, the center of the circle is around here, which is somewhere here. And then it has a radius of 2. So a radius of 2 should be somewhere here. It will pass through this part here. Let me see, the radius is 2. And then this radius is also 2. And then it passes through 2, 2, 2, and 2 here. So let me see here. This, oops, sorry, hold on. It should be around here. And therefore, the circle will look something like this. Okay, and then there you have it. This is a circle centered somewhere here. All right, please forgive me for the accuracy here, but roughly the circle will look something like this. Centered at 4, 4, radius of 2 unit. So 2 unit around here. Okay, and then there you have it. But because this is inequality, don't forget we need to shade the region. So the region will be somewhere here. All right, and then there you go. That is the region represented by that complex inequality. Right, now I hope that is clear. I'm going to move on to the next sections. shortly. All right, let's take a look at the second part of question B now. I have prepared a diagram to illustrate what does the question B actually represent. Let's read it through first. For the complex number represented by points in the region R here, given by this circle, which is indicated by this circle here, centered at 4, 4 here, that has a radius of 2. It is given that the complex number, the modulus of the complex number lie between P and Q. What that actually tell us is the magnitude of the complex number has a maximum value of Q and then has a minimum value of P there. So how does it look like over here then? Okay, it simply means that the the distance, the shortest and the longest distance from the origin. Okay, because we are looking at generally something like this. I'm going to show it to you what this actually mean visually. So we have our circle here centered at 4, 4. Now for the z, for the complex number z, we know that complex number z is represented in general as IB here. And then it actually represents a circle. You can visualize it as a circle with a specific radius. So take for instance, this could be the radius, or this could be the radius, or it could be somewhere here, for instance. This could be the radius, right? So if you are looking at the largest circle that you are looking at right now, this outline here. Now that distance from the origin until here is the value p. So that is the minimum value of radius of this circle z, which is represented by p here. So I hope that is clear here. And then it must be intersecting. The circle that I have drawn in dotted line must be intersecting with the circle that is given here, because the solution need to be found in the region itself. Right? So that will be the shortest distance for this radius of the circle represented by complex number z here. And then that would be our shortest distance for the magnitude of complex number z. And then we can further extend the circle here so that it looks something like this. The largest that we can have. Now by having that, right, we are looking at the maximum distance or the longest distance from the origin here until it touches the circumference here. Right now, my drawing is not that clear here, therefore I'm going to represent it using this drawing here, which is set up by GeoGebra. It's much more specific and accurate. Now you can see that this is the origin. The shortest distance, which is represented by P, is given by this distance here, from here to here. Right, so that will be the shortest distance. And then the longest distance, which is represented by the maximum value Q. Q is basically here. All right, so that will be our Q. All right, so that is the visual idea behind that particular inequality. I hope that is clear. Once you get that visual representations of this inequality, then we can solve it quite easily. All right, let me clear all this here, and then we can start to solve that. Okay, let me do this very quickly here. Okay, and then I'm going to we're going to start off by finding the shortest distance p first. We can find out the shortest distance p. How do we find the shortest distance p here? It's also quite direct. I would say that we can take the distance here. All right, I did not draw very accurately here. So we can take the distance from O to the center of the circle. All right, now let me clear this P first so that it's not very distracting for us. Okay, and then we are interested to find the value for P, which is given by this distance here. All right, to do that, we are going to find the distance from O here until the center of this circle. So I'm going to label that as C. The distance OC can be obtained quite easily. Distance OC is basically just because the C here is 4, comma 4 here. Therefore, the distance would be 4 square by 4 square here, square root. And that would give us 4 root 2. Now, that is the distance from O to C. To find the shortest distance P, therefore, we can conclude that P is basically 4 sub 2, subtract off with the radius of this circle. So we know the radius of this circle is 2 unit long. Here, you can see that. Therefore, we're going to subtract that. And then there you go. That's the value for P there. I hope that is clear. Now, next, using the same idea, we are going to find the longest distance from O until here. So I'm going to call that OP then. All right, we are going to find the longest distance. Okay, maybe I call that OQ then, because this one is Q, so I'll call that OQ here. This is P. So now the longest distance will be Q. How do I find the Q? You can see that very clearly from the diagram. OQ, OQ is just, you can either make use of OP or you can make use of OC then. OQ is OC plus the radius of the circle. And then that would actually give us 4 sub 2 plus a 2 there. And then there you have it. Those are the two values of P and Q that satisfy this inequality. And then the P and Q must be found in the region of R there. Okay, I hope that is clear. Now, next we're going to move on to find the argument. All right, so I'm going to show you the argument shortly. Right, next we're going to answer the second part of this, which satisfy the inequality for the argument. What that actually look like, I have already drawn the same diagram here. You can see the blue straight line. Now, the first blue straight line below here actually represent the line that produce the argument that is greater than alpha here. What I mean is this angle here is the alpha itself. Right? Now that will be the argument of the complex number z that is considered as the minimum angle where this line touches the circle here. And then the angle measured counterclockwise from the x-axis is known as the argument here. And then that is the minimum angle that we can have that satisfy the region R here. And then we can also have another tangent line that is touching the circle at this point here. And then this would actually give us the other argument. That argument will be maximum argument, which is labeled as beta here. All right, now that is the visual understanding of this inequality. And then how are we going to solve this? Okay, in order to solve this, we are going to make use of whatever positions that we know of from the circle itself, especially the center, right? So first of all, the first part will be here. I'm going to draw a straight line down here. And then first of all, let me clean up all this. We are interested to find the alpha, which is this one here. In order to do that, we are going to make use of this angle here. We're going to call that theta. And then theta subtract off with another angle here, beta, for instance. Oh, I shouldn't call it beta because they already have beta there. I would actually call that like gamma. Okay, so I'm going to make use of the angle gamma here, and then by subtracting that with the angle theta, I will be able to obtain alpha. So here I'm going to say that alpha is basically theta, okay, subtract off gamma. That is how we obtain the alpha itself. All right. Now, first of all, uh, the data itself can be obtained quite easily because we know that this is again is 4 unit long, and then the run is also 4 unit long. Therefore, um, I would say it's very clear that the theta is 45 degree then, right? So from there, we can conclude that the theta is 45 degree. I'm going to write down in terms of radian measure, so that it will be 45 degree. Now, the only concern now is the gamma. How do we find the gamma? We're going to draw another line here because the blue line is a tangent, and then we know the radius for this circle is 2 unit long from here. Therefore, we will be able to obtain the gamma quite easily. We know that tangent, or in this case, we can't use tangent anyway. We know the length for OC here just now. We have already obtained the length for OC, which is 4 sert 2. That's the length for OC. And then we can make use of one of the trigonometry ratio to find out the angle gamma. In our case, it will be sine gamma is equal to 2 divided by the length for OC. That would be this. Okay, so if we try to simplify this and then rationalize that, we will get something like this. This is 2, so that will be 1 over, oh sorry, not 1 over 4, it's sert 2 over 4. So it's sert 2 over 4 here, right? And then finally, we can work out the gamma as the sine inverse sert 2 over 4, right? And then by substitute this angle in radian measure, we will be able to conclude the alpha as pi over 4 minus of the sine inverse over here. Right. Now, if you like to leave it as it is, you can. But because the question say three significant figures, then so therefore we have to work out the actual angle in this case. All right. So let's give that a try. Let me try using my calculator here. I'm going to get that as sert 2 divided by 4 here. And then, of course, I need to convert that to radian measure for 8. All right, I will get this as some decimal number, of course. You can key into your calculator. And then after that, we need to subtract that by this number here, pi over 4. And then we will get, from my calculator, is that there's 0.424 here, radian, to the nearest three significant figures. Okay, now I hope that that is clear for the first alpha here. And then as for the beta itself, sorry, as for the beta itself, it shouldn't be a problem because this angle here is also the same as gamma. And in order to get the beta, we know that beta is all the way from the horizontal line until here. This is beta. So in order to get the beta, all we need to do is just take, well, it's up to you actually. You can either take alpha plus 2 gamma, or you can take theta plus the gamma itself. So beta is actually theta plus gamma. We know that theta is pi over 4, and then we just need to add up with the sine inverse sert 2 over 4 there. And then from there, we are good to go here. All right, so I'm going to pause here. I'm going to work out the answer that we have here. All right, so let me work that out one more time. Okay, that is divided by 4 here. Okay, and then I will need to all right, so that is the one that I have currently. And then what I have is, okay, hold on, there's something wrong with my computation. Let me try to compute that one more round. Okay, I think you guys can try out on your own. Shouldn't be a problem at this point. That is, let me check my number one more time in case I make a mistake here. It's always good to check in the exam. Okay, so now I got what I need, and then after that, finally, I need to conclude my answer as 1.15 here to the nearest three significant figures. Of course, you guys can always check my numbers here in case I make a mistake. If there's a mistake there, just drop your message into um, the comment section. Yeah, and then the rest can pick up from there. Right. So I hope this is clear for this question. I'm going to proceed on to the next question requested by the students. Right.